Right, so perfect. Right, so this is the 2H paper. So it's the higher level paper, calculator paper, which we've done the foundation paper for the other day. Now, what you will notice is that the first few questions are identical to the questions at the end of the foundation paper. So if you're doing this paper from scratch, go back, look at the foundation recording, and you'll find that some of these questions are the same. What we'll do is actually, we'll just go through them quickly. So you'll see that some of the questions at the beginning will feel familiar if you went through the foundation paper with me, because they are the same. So if you've got this sign, so this is your set notation, this sign means and. So when you've got it like this, it's and you've got that, you've got or. So the answer to that is A and B. When you're finding midpoints, what you're doing is you're adding up the two x values and dividing by 2, and adding up the two y values and dividing by 2. So 4 plus minus 2. So 4 plus minus 2 divided by 2, and you're going to have 9 plus 1 divided by 2. And here you end up with 2 over 2. So you end up with 4 minus, which is 1, and 9 plus 1 over 2, which is 5. So we get 1 and 5. The next question asks you which of these is a geometric progression. Now, what a geometric means, so what a geometric progression means, it means that every term is multiplied by the same thing, is multiplied, so is times by something to get the next. So it's multiplied by the same. If they'd asked you for is it an arithmetic progression, that would be when you add something and it's always the same. So this one is an arithmetic progression, not a geometric, because 1 plus 2 is 3, plus 2 is 5. Here we'd say, okay, 1 to 3 is timesing by 3. 3 times 3 is not 6. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27, and so on. So this must be our geometric progression. Right, then we've got bearings. So we know the bearing off A from B. So off A from B means, so if I have my point A, actually from B. So we're going to actually start from B. So you start with the second bit. And remember, a bearing starts from north and it goes clockwise. So from north clockwise, I know that this angle has to be 310. When I get here, I know I've got to 180. I've got to 270, so it's a little bit more. I know that this angle is 310, and that leads me to A. Now, if I want to go from A to B, it means I'm starting at A. So this time I'm starting at A, and the angle that they want is this angle over here. Now, what you should know is that angles in a circle add up to 360. So if I have 360 minus 310, I know this angle is 50. And these two angles here have to add up to 180. So therefore this one will have to be 130, which is that one there. You've got a circle, so this is the same as the question we had the other day, because it was also in the foundation paper. So this is knowing your formula for the circumference. So circumference is pi d. So therefore the value that the constant k represents is pi. Right. So we worked through this question before. So what I'm going to do is just quickly talk through it and fill it in very quickly, but not going to spend too long. So our midpoints are going to be 2.5, 7.5, 12.5. Here we multiply our frequency by our midpoint, and we get 30, 52.5, 12.5. We know that the total of this column is 20. The total of this column we worked out to be 95. So the estimate for the mean is going to be 95. So this column here, divided by 20. So divided by this here, which we got to be 4.75. I went through it slower when we went through the foundation paper. So if you're still not sure of it, you can go through that then. Here we calculated and we worked out that it was lower than in part A. Okay, so question 7, also a question which was the same. We opened out the left-hand side, 5 times 7 to give us 35x plus 40 plus 6x plus 3b. And we said that's equivalent to ax plus 13. When we simplify this side, we get 41x plus 40 plus 3b is ax plus 13. And then we can match things up. So 41 matches up with the a, so a must be 41. And then we can match up the other side, and we've got 40 plus 3b must be the same as 13. So 40 plus 3b equals 13, and we get 3b equals minus 27, and b equals minus 9. And like I said, this is also the same as what was in the foundation paper. So question 8, again, we've got a couple more questions before they become new questions for the higher paper. So we've got 2 quarter circles cut from a rectangle. What we did was we split this like this. We identified that the radius has to be 6 centimeters because we could cut it in the other places. So the area of the rectangle is 12 times 6 to give us 72. We've got 2 quarter circles. So 1 quarter circle would be 1/4 times pi times r squared. But we've got 2 of them, so we're going to multiply that by 2. And when we multiply that by 2, so if we had, sorry, let's just write it out like we did in the previous one. When we do that, we get 28.274, and then our area that's shaded will be the rectangle, which is 72, minus 2 lots of 28.274, which gives us 15.5 centimeters squared. Okay. So that takes us, we've got one more, I think we've got 3 more questions, 3 more pages. So what I'm going to do is, this question is identical to the foundation, so is this one, and they're the same until we get to question 16. Okay, so what I want you to do is, if you want to be able to do the questions 1 to 15, just because I'm conscious of the time and wanting to get through the whole paper, have a look at the YouTube recording from yesterday actually, where we went through the foundation paper. Question 1 to 15 is the same as the last 15 questions on the foundation paper. So this is the higher level questions, and we'll start from question 16 properly. So we've got a cumulative frequency graph, and we've got masses of 50 apples. We want to estimate the median mass. Now a median kind of sounds like middle. So the median is the middle number. So what you're looking for is the middle of the 50. So half of 50 we know is going to be 25. So what we're going to do is we're going to take, let's take it at 25, we're going to draw a line, and you would do it with a ruler. So you draw a line until you get there, then you'd read off the value it gives you, my very dodgy line, but that value it gives you down there is going to be, so this value here that is just slightly after 105, so the answer is 106 grams. So when you're looking for a median from a cumulative frequency graph, you look at that column, you take the maximum amount, can you see it's 50, and it should tell you in the question, you half it and you read off the value, and that's going to give you the median. The next question then asks you to estimate the apples that have now this is the key word here. So the key bit here you have to be careful of is they want greater than 115. So in the same way we did before, we're going to read off the value for 115. So we're going to, this time we're going the other way. We're reading 115, we're going up, and we're going to read across. And when you read it across, we get to, you get here. Oh, it's not letting me show. So you get over here. So you end up with 42, right? So that's, so 42, now a cumulative frequency gives you everything underneath. So actually the amount greater is the difference between 42 and 50, which is 8. So that would be the amount. Now let's go have a look what the question said. The question didn't ask for the amount, it asked for the proportion. So when you see the word proportion, your brain should go fraction or percentage. It doesn't matter which one you use. So proportion tells me a fraction. Greater than 15, we said there were 8 of them. A fraction is out of something, so it's 8 out of 50, which if we cancel down would be 4 out of 25, or you could change it into a percentage and it would be 16%. So either answer would get you all the marks. So when you see the word proportion, you're going, I need a fraction, and you go and you have a look at it like that. All right, let's have a look at question 17. We've got A is a prime number. So remember, a prime number is a number that can only be divided by itself and 1. B is an even number. Okay, so an even number. And what else do we know about prime numbers? Prime numbers are always odd except for the number 2. 2 is the only even prime number. All right, so it's telling us n equals a squared plus a times b. Right, so if we have a prime number times an even number, so any number times an even number is going to become an even number. So we know we've got a squared plus an even number. Now we know a prime number can be even because we can have 2, at which point we'd have an even plus an even, which gives us an even. But if we had any others, we would have an odd plus an even, which gives us an odd. So that tells us it can be an even or it can be an odd. So could be even or odd. So when you're doing prime numbers, remember 2 is your only even prime number. Okay, so we've got a bag has 20 discs. 10 are red, 7 are blue, and 3 are green. Marnie takes a disc at random before putting it back in the bag. Okay, Nick then takes one and puts it back. Ollie then takes one. Okay, if they all take a red, it means that M takes a red, N takes a red, and O takes a red. So the probability that anybody takes a red is going to be 10 out of 20. Now they're putting it back each time. So remember, and, so if you want to think about it, and in probability you think of as times, and or you think of as plus. But this is Marnie and Nick and Ollie. So it's 10 out of 20 times 10 out of 20 times 10 out of 20, which is a half, I know it's a calculator paper, but you should be able to do this. So 1 times 1 times 1, 2 times 2 times 2. So the answer would be 1 over 8. Okay. Part B. So all 20 discs are in the bag. Reggie takes 3 discs at random, one after the other. After he takes a disc, he does not put it back. So he's not putting it back. His first disc is blue. Work out the probability that all 3 discs are different colors. Now the first one's blue, so we don't care about the fact the first one's blue. It's done now. So he's not picked, so the blue is already done. So if they were going to be all different colors, it means the other 2 that he picks has to be a red followed by a green, or a green followed by a red. So we're going to think of the probability that it's red and green, or it's green and red. So remember, he's not putting it back. We started with 20 discs, and the bit the previous question told us was that 10 are red, 7 are blue, and 3 are green. Now remember, we're not worrying about the blue ones because he's already picked a blue. So these are the other 2 options now. We're going to now turn these numbers. So if he's picked one already, there's now 19 left. The fact it's going to be red will be 10. And then remember we said and, I'm going to keep writing this, and is times and or is plus. So because it's red and green, we're going to replace the and with a times. And now there's still 3 greens, but there's only 18 left. Or the other option is it's the other way around. We'll have 3 out of 19 times 10 out of 18. And then when you stick that in your calculator, you'll get 5 over 57 plus 5 over 57, which your answer is then 10 out of 57. So in probability, really, really important, and times or plus. And you should find all your probability questions, hopefully quite easy. Right, question 19. Lunch. You get to choose 1 starter and 1 main. There are 4 starters and 10 mains to choose from. 2 of the starters and 3 of the main courses are suitable for vegan. What percentage of possible lunches have both courses suitable for vegans? Okay, so first of all, let's think about the total number of possibilities that we could have. So the total possibilities are 4 starters and 10 mains. So the same probability thing works here. So 4 times 10 gives you 40. So there's 40 possible combinations of picking a starter and a main. 2 of the starters and 3 of the mains are suitable for vegetarian. So 2 times 3, there's 6 combinations that are suitable for vegetarians. We want a percentage. So we see percentage and we think out of 100. So first we come up with the proportion, which is 6 out of 40. And if it's out of 100 and making something a percentage, we times it by 100. And when you stick that into a calculator, you should get 15%. We've then got n is a positive integer. And we want to prove algebraically that this, what we've got here, is a cube number. So let me see if I can make this a little bit bigger. So we're trying to prove that that's a cube number. So in order to do that, the first thing we're going to do is open out some of these brackets. So what we're going to do is we're going to say 2n squared times by 3 over n. So we times the numbers together. 2 times 3 is going to give you 6. Then you've got n squared, and if you like, it's divided by n. So one of these is going to, so that's going to cancel that out, and you're just left with n. So when you do that, you're just left with 6n. Then you've got 2n squared. So then you've got 2n squared times by n, which gives you 2n cubed. Then you've got here 6n times n squared to give you 6n cubed. 6n times minus 1 to give you minus 6n. And when you clean that up, you can see, sorry, this should be a cubed. It said cubed, but wrote squared. There we go. You've got 6n minus 6n, which is just going to disappear. You're going to have 2n cubed plus 6n cubed, which gives you 8n cubed. You want to show it's a cube number, which means you want something all cubed. Now we know the n is cubed, and we want something cubed gives us 8, which will be 2. And these 3 dots mean therefore cube number. And you've proved that it's a cube number. Right, let's have a look at the next 2. So the next 2 are looking at proportion. Oh, the next one anyway. No, both of them are looking at proportion. Okay, so if I scroll it up, we've got y is inversely proportional. Okay, so what you need to remember is when you see the words, so if it had not said inverse, say it said directly proportional, you see the words directly proportional, you're going to write k times. You see the words inversely proportional, you're going to write y equals k divide. So in this case, we've seen the words inversely proportional. Our brain is going to go, I have to write k over something. So this is k times something, this will be k over something. So we're going to write y equals k over something. Now to find out what that something is, we read the rest of the question. The question says it's inversely proportional to root x. So on the bottom of this equation is root x. So inversely proportional, you see those words, you straight away, your brain's going to go k divided by something. So now you're going to sub some numbers in. We know y equals 4, x equals 9. Square root of 9 is 3, so we can replace 3 there. So k is going to be 4 times 3, which is 12. So k is just this value that we've, not value, but this symbol we've made up to help us write this equation. So now we know that y equals 12, which is what our k was, divided by root x. And that would be your equation connecting x and y, which means if they give you any numbers for x or y, you can now do some calculations, which is what the next bit requires you to do. So the next part of this question tells you to work out the value of y when x is 25. So remember, we calculated in the previous bit that y is the same as 12 over the square root of x. So we know when x is 25, y equals 12 over the square root of 25. The square root of 25 is 5. So 12 divided by 5, you plug that into your calculator and you would get 2.4. So, okay, 22. We want to simplify fully. So we've got an algebraic fraction here, and we want to simplify it. So what we're going to do is we're going to factorize the top and the bottom separately. So we're going to think about them separately. So if we take the top, what can we see that we can take outside of the bracket? The biggest factor of x that we can take outside of the bracket on the top is x to the power of 3. So if I take x to the power of 3, how do I get x to the 5? I've got to multiply it by x squared. And then I've got to multiply that by 4. So that's my first step. On the bottom, I can't take any x's out, but hopefully you can see you can take a 3 out. So you'd have x minus 2. Then you look at the top, and I don't know whether you recognize this, but you will get better at these, is if you have a look, this is what we call a difference of 2 squares. So whenever you see any kind of factor where you've got something squared minus something else squared. So I'll call it A instead. So A squared minus B squared. We know it can be written as A plus B, A minus B. So you should recognize that the X is squared and the 4 is the same as 2 squared. So you can now write that as X cubed, and this can become X plus 2, X minus 2. And we've got that all over 3X minus 2. Now we can see we've got the same thing on the top as we have on the bottom, which is this X minus 2. We can cancel them out, and our final answer would be X cubed, X plus 2 over 3. And that would be simplified fully. Okay. Question 23. We've got PQR is a straight line. P to Q, Q to R is in the ratio 3 to 1. P to Q is A. And we want to know what R to Q is. So we know going from here to here is A. So we know that this bit is A. If this bit is A, this bit is smaller than it by a third. Do you agree? So 1, to go from 3 to 1, we're dividing by 3. So this bit here, from Q to R, must be 1/3 A. But it's not asking us from Q to R. It's asking us to go from R to Q. Now, whenever we go against an arrow, so when we go against the arrow, it becomes a minus. So to go from Q to R is 1/3 A, and to go from R to Q will therefore be minus 1/3 A, because we're going in the opposite direction. Right. 24. Let me try and make this a bit smaller so you've got the question on one page. We've got a curve and we've got to sketch fx plus 2. So the question is asking us, if I just make it bigger, sorry, my phone, apologies to anyone on TikTok, I thought I had put it on do not disturb. My phone keeps ringing. So we have to sketch the curve x plus 2, which is inside the bracket, so it's affecting the x coordinates, and you're going to shift it. Remember, the x's do the wrong thing. So instead of adding 2, it's like your ex-boyfriends and girlfriends, the x's do the wrong thing. They're going the other way. So instead of adding 2, we're going to subtract 2. So what we're going to do with this graph is every single point on the x is going to move. So this whole graph shifts 2 along. So instead of 1 here, it becomes -1. And this point becomes, this moves along to here. Try plot as many of the sort of points as you can. So when you join it up, oh God, see, you don't do what I did. And it looks the same, but shifted along. So the idea is the graph shifts 2 to the left. Okay. Right. Question 25. So we're almost there. All right, so question, how many questions have we got? I think there's 28 questions in total. So question 25. We've got ABC and ACD are triangles. So let's think about what we have here. We've got 2 triangles. We notice straight away that one of them is a right angle. So we can see that one of them is a right angle. So this triangle here is a right angle triangle because of our right angle here. So in our heads, we're like, okay, that's good. It means we can use SOHCAHTOA and Pythagoras on that triangle. The other triangle isn't a right angle. We want to work out the value of x. So what do we know? This triangle here, so the triangle ABC shares the line AC with ACD. So what we can do is find the line AC. So in order to do that, we're like, well, we want this side here. This side is the opposite. We know the adjacent. We think of our SOHCAHTOA. And we're like, okay, we're going to be using tan. So we know that tan 49 is the same as this AC that we want divided by 16. So AC will be 16 times tan 49, which gives us 18.41 centimeters. So now what we have and what we found is this distance here. So we now know that this is 18.41. And now we've got a triangle that's not a right angle triangle. So we can't use SOHCAHTOA, we can't use Pythagoras. We can, however, use the sine rule and the cosine rule. So the sine rule is the one that's A over sine A plus B over sine B, sorry, not plus, equals B over sine B. And the cosine rule is the A squared equals B squared plus C squared. So we know we can use one of those two rules. So what do we want? We want an angle, and we have the side that's opposite it, and we've also got another pair, which tells me I'm going to be using the sine rule, but because I want an angle, I'm going to flip it so the sine's on the top. So what we're going to say is sine C, because C is the one we have, over small c, equals sine B, which we want, over small b, which is the one opposite it. So this is small b and this is small c. So we have sine 35 over 20 equals sine x over what we've just found out, our 18.41. So sine x will be sine 35 over 20 times by 18.41. And we're just going to leave that in our calculator. We're going to calculate it, and we should get something like 0.52 something. And we're going to leave that in our calculator, and then we're going to do shift sign and hit the answer button. So we're not going to lose that number that we have in our calculator. And you should get 31.9 degrees. And generally try do things to 3 significant figures. All right, let's have a look at question 26. So this is a functions question. So those of you in year 10 who I imagine might be watching this right now, you may not have got this far. We're now getting to the level 8, 9 topics. So don't worry too much about it, but I'll try to talk through it relatively slowly so you can see how it's done. So if you're told to work out FGX, what that means is you're putting the second one, which is the G, into the first one, which is the F. So you're going to take G and you're going to put it into F. So wherever there is an X in the F, you're going to put the whole of the G. So if you have a look so we've got an X here and an X here. So instead of those 2 X's, we're going to replace it with all of this. So when we do that, we end up with FGX is x squared minus 2 over x squared minus 2 plus 2. Because that's a plus 2 there. Right, so now we just clean that out. We leave that as x squared minus 2 on the top. Minus 2 plus 2 cancel out and just leave us with x squared. But they want it in this form. So they want us to split that out further. Remember, if there's one thing on the bottom, that means everything on the top is divided by that thing on the bottom. So we're going to get x squared over x squared minus 2 over x squared. And so x squared over x squared is just 1. Got minus 2x. So 2 over x squared. Let's not skip any steps. And then we look again. So we've got our A, which is our 1. But it hasn't, we want this x to the power of n. Now our indices rules tell us that if we have 1 over something, so 1 over x to the 1 is x to the minus 1. 1 over x squared is x to the minus 2. 1 over x to the a is x to the minus a. So we've got x squared here, so it'll be 2x to the minus 2. And that's to get that final mark there. But remember, these are the last 3 or 4 questions of the exam paper. They're going to be tricky. They're your level 9 questions. So the idea of this is to figure out what topics it is, if you are doing the higher in year 10 that you've not covered, so we can cover them. But I think this is the best way to work it out, is by going through some of these papers. Right, so 27. 27 tells us we've got a point and it lies on a curve. And you want to show that the point a half also lies on the curve. Okay, so first we've got that point and it's a weird curve. So we're going to substitute in 3 and 1 over 64. So we've got y equals k to the x. We've got, this is our x coordinate, this is our y coordinate. So we're going to say 1 over 64 equals k cubed. To get rid of a cube, we have to take the cube root. So this tells us k is the same as the cube root of 1 over 64, which is a quarter. So like with that proportion question, we can now replace the k with a quarter. And now it says show that. So we can just substitute it in. So we're going to sub in x equals a half. So we're going to say y equals a quarter to the power of a half, which equals a half, and you're done. You've shown that it works, because when you sub in a half, you get a half. And it's one of those questions, if you can do, you get the right answer and you know you've done it right, and you know, makes you happy, hopefully. Right. Izzy runs a race. Okay, so this is the last question. So Izzy runs an 80-meter race in 14 seconds. During the first 6 seconds, her speed increases at a constant rate. That means the gradient is the same. During the last 8 seconds, her speed increases at a different rate. Okay, so again, the gradient is the same. Her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. Right. So I am going to call this point, I don't know, let's call that V, because we normally represent velocities or speeds with a V. We know that the speed at this point is 2 less than the speed at that point. So we know that this is V minus 2. Hopefully that makes sense. So we're told the speed at this point is, the speed here is 2, the speed here is 2 more than the speed here. So this must be V minus 2. So this is at 6 and this is at 14. Okay. Now, if I wanted to find the acceleration is given by the gradient. So the gradient is your change in y over your change in x. So the first bit is quite straightforward. If we have a look, it wants it for the last 8 seconds. So we know that's 8. We've already been told that the difference here is 2. So therefore, it's your change in y over your change in x. So it's going to be 2 over 8, which is the same as a quarter. So you could write that as 0.25 meters per second. And that's your acceleration for the last 8 seconds. The next bit of the question says she finishes the 8-meter race, her speed is V. Work out the value of V. So now it wants you to work out what actually we've already named as V there. So we know the whole thing is 80 meters. Now, the important thing with a distance, with a speed time graph, your distance is actually your area under the graph. So if I was just to get rid of some of these, let's get rid of this. And we're going to try find the area under the graph using the values we found. So what kind of shapes do we have? So we could think about it as a trapezium. We could think about it as a rectangle and two triangles. It doesn't really matter. You want to split this shape up to be able to get there. So if we have a look, we've got a triangle here. And for this triangle, this is going to be half the base. So the base is 6. So half the base, which is 3, times the height, which is v minus 2. So that's the area of that triangle. Here we've got a trapezium. Now the formula for the area of a trapezium is half the sum of the parallel sides. So your parallel sides here are v and v plus 2 times the distance between them. So if you haven't heard the really irritating song that, you know, goes to pop goes the weasel, half the sum of the parallel sides, I'm not going to start singing, sorry, times the distance between them, and that's how you calculate the area of a trapezium. So you could do that, or you could split it into a rectangle and a triangle. So let's do that over the page. So if I find a clear, actually, what I'm going to do is write it on the side here. So you can see the question, apologies again, you can see the question at the same time. So the area of this bit is half the base, which we said was 3, times the height, which we had as v minus 2, and that was v. And then the trapezium, we're going to add half v minus 2 plus v times the distance between them, which is 8. And all of that equals 80. So when you clean that up, you've got 3v minus 6. And here we end up with half of 8, which is 4. So we end up with 8v minus 8 equals 80. So we'll get 11v minus 14 equals 80. 11v equals 94. So v must be 8.5 meters per second. Okay, so I hope you followed that. Sorry, that last bit was a little bit disrupted, but that's the entire paper for 2H. What I would like you to do is either comment on the YouTube video, or if you can comment in any of my videos on the topics from that, year 10s especially, that you've not covered yet, because that's what I'm trying to identify in order to cover them. With science, I'm working backwards through the topics. So I'm starting with the latest topics. So at the end of the specification, so I'm assuming you've not covered those, but with maths, it's a little bit trickier. So if you know that you definitely, for example, I saw someone had said, hadn't done the sine rule, let me know and I'll make sure I cover it. So I hope that was useful, and yeah, I'll try clean the videos up for us to go through. Right, and